You know that golden telescope we humans built that's taking some mind-blowing pictures of space right now? Well, it turns out it's so powerful, it might have just shattered our understanding of the universe.
There should not be primordial galaxies that are bigger than the Milky Way galaxy that are only 500 million years old. Something is wrong. We may have to revise our theory of the creation of the universe.
The very first findings from the James Webb Space Telescope appear to imply that large, bright galaxies had already formed during the first 250 million years after the Big Bang. Thus, if this were to be proven, it would throw the established framework for cosmology, Big Bang, into severe question. However, for the time being, it remains a significant if. Join us as we unveil the mind-blowing truth about the Big Bang. The astronomical preprint service Arxiv was filled with articles claiming the finding of galaxies that are so far away that it took their light around 13.5 billion years to reach us shortly after NASA released the first batch of scientific data collected by the JWST. In addition, standard cosmological models are used to explain the structure and development of the universe, but many of them seem to have a greater mass than those models predict. Also, Michio Kaku comments, "It worries me slightly that we find these monsters in the first few images," and we agree with him. Regardless of the beliefs you hold, the latest photographs of the cosmos that have been produced by the JWST are astounding and stunningly beautiful. The majority of people are left wondering, in astonishment, how everything got to this point. On the other hand, lately there has been a lot of discussion on the internet about how these photographs could truly indicate that the Big Bang did not happen. Obviously, there are those people who think that such conclusions are founded on misinformation and misquotes. It is premature to make definitive claims about what the JWST confirms or does not prove. However, it is unquestionably positive that it has rekindled people's interest in scientific investigation and prompted them to delve further into the question of how their lives should be lived. We may give thanks to God that we are able to have a firm grasp on the explanation for the cosmos that is found in the Bible. Because the Bible is accurate so many times when predicting the future, we know that we can trust it when it comes to predicting the past. Despite this, there are still many unanswered issues about the Big Bang theory. The first law of thermodynamics stipulates that matter cannot be generated or destroyed, hence its violation would constitute a violation of this law, according to the critics. They further claim that it breaks the second law of thermodynamics, which deals with entropy. Still, others cast doubt on the very idea that the cosmos is undergoing any kind of expansion at all. Should it be shown that this doubt is justified, the whole theory would be rendered invalid. However, there are far more fundamental problems that the JWT still needs to answer and may never be able to answer. To begin, we have to ask, where did that very sweltering and compact singularity originate? Some people are going to claim that it sprang from absolutely nothing. Stephen Hawking, who passed away in 2018, was a renowned cosmologist who once said, "Because there is a law like gravity, the universe can and will create itself from nothing." Others have previously pointed out the various logical and scientific flaws with that statement, which seems to have been constructed in an effort to get away from the need for a creator God, which for many people is inherent in the Big Bang theory itself. However, when the theory was initially offered, the governments rejected it because if the cosmos had a beginning, something had to have started it. According to John chapter 1 verse 3, all things were made through him, and without him, nothing that was made could have been made. The fact that the cosmos did not exist in the past but was later brought into existence is compelling evidence that God was responsible for this event. How experts found these galaxies. Radiation of a very high energy level is sent into space by newly formed galaxies by their young, massive stars. And because this light has been traveling through an ever-expanding universe for billions of years, its wavelengths have been redshifted all the way into the infrared. Thus, Webb's sensors are sensitive to this kind of radiation. It is only by thorough spectroscopic measurements, which may be carried out by Webb's spectrometers, or by the ground-based ALMA observatory, which works at even longer wavelengths, that it is possible to correctly establish the redshifts. This allows one to estimate how far out into space one is seeing, and hence how far back in time one is looking. Nevertheless, there is a speedy alternative that provides a preliminary estimate. In the vast reaches of intergalactic space, neutral hydrogen atoms are able to selectively absorb ultraviolet light with wavelengths that are shorter than 91.2 nanometers. This threshold caused a redshift to longer wavelengths for distant objects even into the infrared for the most distant galaxies, as the light travels farther away. Due to the fact that the near-infrared camera known as NIRCam on Webb gathers readings via a huge number of filters, each of which covers a distinct wavelength band, a galaxy may be visible in certain channels, but not in others. Also, the wavelength band in which the galaxy is no longer visible provides an approximate indication of the galaxy's redshift as well as the associated look-back period. What did the experts do? Therefore, two separate groups of astronomers quickly reported their findings based on this method within only 6 days following the release of Webb's initial scientific data. Both groups, one headed by Rohan Naidu, Center for Astrophysics, Harvard and Smithsonian, and the other by Marco Castellano, Rome Observatory, Italy, uncovered two rather bright galaxy candidates with redshifts of around 11 and 13, dwelling in a universe of the order of 400 and 325 million years old. In the days that followed, another two separate teams, headed by Callum Donnan from the University of Edinburgh and Yuichi Harakan from the University of Tokyo, presented the intriguing discoveries of an unusually huge galaxy with a redshift of 17. This means that we are just 225 million years from the Big Bang when we look back in time. In yet another research, Haojing Yan from the University of Missouri and his colleagues stated that some of their candidate galaxies might potentially achieve a redshift of 20, which would be equivalent to 180 million years after the Big Bang. Mariska Creek, an extragalactic astronomer at the Leiden Observatory, speculates that some of these organizations may have prepared major portions of their article in advance, leaving them with just a few numbers and other details to fill in. Being the first is just something that has a lot of significance for certain individuals. Thus, everyone is quite inquisitive about what exactly is included in the data. On Twitter, the senior scientific advisor for the European Space Agency, which is a key partner in the Webb project, made the following comment: "I'm confident some of them will be confirmed, but I'm equally convinced that they won't all be." At this very moment, everything does feel a little bit like a surge of sugar. To present, scientists have discovered potential candidates for distant galaxies in 4 different regions of the sky. Some people search the area around SMACS 0723, 73, which is a galaxy cluster located in the southern constellation Volans, the flying fish, and was included in the very first picture that was published by the Webb telescope. In Sculptor and Boots, others carefully examined the results of 2 ongoing surveys: the Grism Lens, Amplified Survey from Space, GLASS, and the Cosmic Evolution Early Release Science, SEERS. In addition, 3 potential candidates were found in another picture that was released early. This image was of Stephan's Quintet, which is a cluster of galaxies located in the constellation Pegasus. It is difficult to keep track of all of the new discoveries, in part because every team employs its own system of numbering. For example, the candidate galaxy with a redshift of 17 has been given a number of different names, including CR2Z171, ID 93316, and Sears 1749. This particular galaxy is also illustrative of a few of the challenges that come with locating distant galaxies in this manner. It is possible that it is a much closer galaxy that is so dusty that it seems to fade at longer wavelengths in the same manner as more distant galaxies do. As a matter of fact, it has acquired the name Schrödinger's galaxy due to its indecisive character. This galaxy is said to be at a redshift of 5, which would indicate that it has a look-back period of a mere 12.6 billion years, according to a group of researchers from the National Astronomical Observatory of Japan, headed by Jorge Zavala. And that wraps things up. We appreciate you taking the time to watch this video. Please hit the subscribe button and we'll see you in the next one.